Hi, everyone. My presentation topic is pneumonia detection using an ensemble of deep learning models. As COVID-19 has been spreading globally and affecting people in every aspect of their daily life, lots of scientists and researchers have been delved into figuring out the series of sequelae and potential symptoms along with the pandemics, among which pneumonia is regarded to be one of the most serious illnesses caused from COVID. Though I'm not a professional who works as a doctor or epidemiologist, my motivation toward the topic is derived from my mother, who works at the ER department and had a long time dealing with patients infected with coronavirus for the last 3 years. At home, she and I will spend large amount of time reading relating papers and realize that it is important for doctors to have instant and accurate diagnosis of pneumonia based on their X-ray images, so that they would offer treatment in a very effective way. Therefore, with a great enthusiasm toward interdisciplinary study of pneumonia, detection methods, and machine learning, I choose to further develop my personal interest by replicating the paper, which is called Pneumonia Detection from Chest X-ray Images, using a novel weighted average ensemble model through deep supervised and semi-supervised learning models to analyze the process of biological image classification and the pneumonia detection. More specifically, the project involves deep learning models, semi-supervised learning models, transfer learning models, and ensemble learning models. It totally implements 7 deep learning models, which are GoogleNet, ResNet 18 pre-trained, ResNet 18 pre-trained GoogleNet, KNN with pre-trained ResNet 18, average ensemble model, and weighted ensemble model. The ensemble model consists of GoogleNet and ResNet 18, different from proposed model by Condu, the editor, which contains GoogleNet, ResNet 18, and DenseNet 1-to-1 with weighted average. With the increasing of layers of deep learning models, there are problems such as overfitting and large parameters coming subsequently. GoogleNet aims at building optimal sparse structures using local compact structures to achieve high efficiency. The sparse structures, called inception module, help to deepen the structures of the network for better performance. The whole network contains 22 layers network with classifiers in some layers rather than one classifier in the last layers, as common deep learning models. In this case, the information of labels can guide the middle layers correctly and make the gradient pass efficiently to solve the problem of gradient vanishing. In computer vision tasks, there usually needs large dataset to fully train models to expectations. However, to label and process data, it will cost a lot of labor resource. The available datasets are limited. To solve the problem of lack of data, researchers tend to use transfer deep learning models, which has been pre-trained on a large dataset, then tuning the models on their data to complete specific tasks. Semi-supervised learning model is the combination of supervised learning and unsupervised learning. It generally utilizes both large dataset without label and labeled dataset recognition tasks. As advantages, it requires as few labor resource as possible to do labeling, but at the same time, it achieves relatively high accuracy. To improve the base models, it usually optimizes features or builds more complex models. The classifiers have different characters. Ensemble learning models are proposed to incorporate their advantages and perform better than a single classifier of it. The common models are voting ensemble, average ensembles, stacking ensembles, and blending ensembles. The report 7 deep learning models trains on Harmony dataset and RSNA pneumonia detection challenge dataset and uses accuracy to evaluate the performance of them. The dataset is shuffled and divided into 3 sets: training, validation, and test. There are 30 epochs in the training process and validation sets for avoiding overfitting. And because the data is balanced, which means the number of normal samples is the same as pneumonia samples, it chooses accuracy as evaluation matrix, which is shown below. The results of different models are as followed. The accuracy of normal images of training dataset and validation dataset in the GoogleNet training process is shown below, and the loss of normal images are shown. The accuracy of pneumonia samples of training dataset and validation dataset in the ResNet 18 training process and the loss of pneumonia images are shown below. The accuracy of normal samples of training dataset and validation dataset in the ResNet 18 training process and the loss of normal images are shown below. To help doctors make diagnosis at the early stage of pneumonia, the project reproduces the deep learning models of the research of conduit for image recognition. It has great meaning in optimizing the treatment and save patients' life, especially under this COVID-19 pandemic period. This project has implemented 7 deep learning models to classify normal chest X-ray images and pneumonia chest X-ray images, and it draws conclusion that the weighted ensemble of deep learning model performs better than the base method. The ensemble algorithm and novel strategy for weighting of conduit has been recreated in this project and proves its superiority. However, there still some models have not been reviewed and validated in more datasets. The future work can also compare with the different state-of-art deep learning models to test the methods.